Well, hi, good morning. Thank you for joining me here in my shop on June 3rd, day 2 with this great big radio, and I've gotten very excited about this radio. um, and the reason is I spent the evening last night reading through the manual for the radio, and I also took a look underneath. I've taken the bottom off. The radio has a panel, with the feet hooked up to it, screwed to it, and I looked underneath, and now you're going to get the same thrill I got. I'm just going to tip this radio up, and you can look under this thing. Maybe have the same reaction I had. Here we go. Maybe a little hard to appreciate in a camera, a flat screen you're looking at, but this is a really well-built radio, and it contains few, if any, classically unreliable parts. And what I'm really talking about are wax capacitors. There's none of them in here. This is full of highly reliable mica and disc capacitors. Yes, they can fail. Oh my, there's a lot of them in here. So chance of one of them being bad or problematic is pretty good just because of the numbers. But on the other hand, is there general deterioration occurring in here of any significance? Maybe not. This may perform pretty much like it did when it was new, even as it is now, except for one factor which I'm going to talk about. But when it comes to the quality and condition of all the parts in here, it's fantastic. I looked very carefully last night. The workmanship is excellent. This isn't a radio that was coming off the end of an assembly line one every minute. I don't think that's what this was. So, fantastic. Just a few little things here I've noticed because I've just started looking at it. It has the sectionalizing plates here to separate the different stages from each other, so as not to cause mutual interference or signal leakage, accidental signal leakage. There isn't too much else to say beyond that, other than wow, this is fantastic. I really thought I tipped this up and there'd be 40 capacitors falling out of it from old age, but no, not at all. So what could be dragging down this radio's performance? Because it didn't seem to be great by any means. It could be my lack of operating experience, although this isn't a complicated radio to operate. I think it could be alignment. Alignment could be the issue, and I think that's the first thing I'm going to approach. One of the reasons for doing that, normally you don't do an alignment at the start, you do it at the end. In this case, since it looks like there could be literally no parts that need to be changed, that would gain some kind of significant advantage, save some electrolytic capacitors. There's a few in here. I think I saw a couple more small electrolytic capacitors. Those might be worth changing out at this point. And there's nothing left to explain the radio's performance other than alignment. If everything here is good, I tested all the tubes, they all tested really good. Also suggests that this radio is not a high mileage radio. It didn't get used a lot. Its condition is like new. It's fantastic. Did it never come out of the box? Spent its whole life in a cardboard box, and now he's out and free on my bench. So a lot of radios, when they're covered like this, they have a cover, they're this basically inside a sealed metal box. They do preserve much better than other radios that are more open to the environment. So my watch is telling me something is done. So I guess I might accidentally started a timer on it or something like that. Well, alignment. So to do an alignment on this radio, I need to study that manual very carefully. Now, let's flip it up again. There were some things under here. Were there not that needed adjustment? Yeah, way up in this area here. All kinds of adjustments. So we got to get at the RF side of things from underneath. The first part to align is the IF part, the intermediate frequency stages. They are probably in these tall cans. Now I see they have slugs, so they're oh, look down here a little further. These guys here. So these have to be adjusted from the top and the bottom too. So again, the radio's got to be up on its side. For them right here. Let's just look at those underneath. So it's in the center and the back. Oh my, they don't look the same. There's two here and two here. These are the ones I was looking at, but the bottoms, they don't look at all. They look like something's missing. That's a little odd. Let's just take a closer look here. So I'm expecting to see a shaft sticking out. Let's give the autofocus a chance. Here he comes. Where's the shaft? They're all missing. That's a little odd. What is going on here? There is no lower slug. There's usually two transformers separately wound close together inside, and each one has its own slug. What is going on with my phone, which keeps telling me something is done? It's great having this phone here. Once in a while it actually has the time on it. See? Yeah. My phone's too complicated. Well, you know, what I was expecting, you know, if you're familiar with this, I was expecting, you know, something like that sticking out of the top. It's not sticking out of the top. A single slug tuning? I guess it's possible. We'll have to look this. We'll have to look at this in the manual. For sure. While I've got this camera out, let's just look at this electrolytic capacitor here. And this one. It all appears to be in good shape. This is a crystal here. Can we read the... No, not with this camera. Oh yes, 1700. Well, this radio talks about 1650 kilocycles quite a bit. 1700, how does that fit? And anything else worth looking at closely? I don't think so just yet. So what I'm going to do is I'm going to get a look at the manual again. I'm going to read through the alignment steps, the IF frequencies in this radio. I'm not even sure. It's a dual conversion radio, which means it converts the incoming frequency twice. And one of the conversion frequencies is 1650 kilohertz, I think, and the other one is 50 kilohertz. 455 kilohertz doesn't appear anywhere in the scheme of things with this radio. So I got to be a little more sure of that. Got to know what frequency, what alignment areas go with what frequency, all that kind of stuff. Yeah, a lot of stuff to sort out here before taking any kind of action. Well, it's taken a long time to sort out the test point locations in the back of the radio. There's a test point A and a test point B. If I got it right, this is test point B here. It's going onto a voltmeter. This voltmeter back here. This is a very high impedance voltmeter. And the signal generator output, which is here, which goes to a test point located here, or just a point in the circuit really. There's no distinct test point set up. There's no special terminal. Some radios they actually have it arranged so the terminal is kind of obvious that it's a test point. Not here though. So I think I have this right. I'm allowing my signal generator to warm up. It's already warmed up. And 50 kilohertz is where we're starting. I don't think I've ever run my signal generator so low. I don't think I've ever even put it on the low band here. 30, 50, well, how come you're jumpy at 50? What's going on there? It's jumpy at 50. And the signal generator is actually very, very stable, but not so stable. Right around 50. Seem to want to act up. Might have to use a different signal generator. 50 kilohertz. Do I have another? Probably somewhere in here. So I don't know if that's just my my digital reading that's jumping around or the actual frequency is jumping around. But we'll figure that out as we go. We'll let that warm up anyway a little bit, and the radio itself needs to warm up. So we need to start this guy up now. Volume is here. Volume down. I don't have a speaker. I have a resistor here to act as the speaker, but we can still hook up a speaker in parallel with it as long as I don't turn things up too high. There can't be any harm in that. It might be a little quiet, but this will at least get us a chance to hear something. But when I'm doing the test itself, we'll just have the resistor and no speaker to listen to. The instruments are not connected other than the grounds. I think we're all set here. How do you turn this guy on? That's on. What's this wire jumping around? The switch contacts are jumping at the back here. The on-off switch, they're jumping a little bit. It's making this black wire move and it's causing this yellow wire to jump a bit. It's nothing, in other words. Okay, let me plug this guy in. And so we have no input to it, signal generator or otherwise. Let's start it up. Start it up by turning on the power. That would be a good idea. Turn on the power here. There we go. So I have the dim bulbs are bulbing away there. And I'm just going to wait a couple minutes to make sure this is not catching fire. I was very careful putting in these clip leads to make sure it didn't create a short. I'm pretty sure I got them on the right spot. Double, triple check them. But goodness knows, I could still be quite wrong. So we're having a nice day here. No, it's going to be a little bit cloudy, but the temperature's going right up. Nice day. Temperature's going up to 30, 31 here with humidity, so it's going to be very uncomfortable. But I've got outdoor work I got to do. I should probably be doing that right now and then do this later in the day, but that causes video posting problems and whatnot. Later in the day, I'm not so inclined to do this kind of stuff either. I'm more inclined to do simpler things. Okay, what do we hear coming out of this guy? Maybe hear nothing. Okay, I will touch the antenna. Let me just grab the volume control here. Antenna's here. So we got some function. And the band we are on the not the first band. The lowest band didn't seem to work at all. We're on the next band up. That's not what the instructions say, but that's good for a start. Radio's operating. Let's give it the full treatment here. So I'm watching the line voltage, 111. Now we can hear the radio more. Volume. I left the volume right up. So if I turn it down and stick my finger on the antenna, there we are. If I tune it a bit, yeah, doing something. Okay, radio certainly appears to be working. Next thing we want to do is hook up this voltmeter here and see what happens. It's really kind of an out of focus picture in my camera, isn't it? I don't think I can fix it though. Okay, you can see the pointer though, that's the main thing. We're going to hook this up to the voltage test spot, that's this white one. Nothing happening. That's a 30 volt scale. It's a 3 volt scale. There's a little wee bit happening there. Let me just put it right on. Now, my guess is what we've hooked up to, in fact, it's more than a guess, I could see on the schematic. We've hooked up to one of the diodes in the detector tube. So probably what we're going to generate is a diode result, or a rectified result from the signal going through the tube. AVC voltage, in other words. We should be able to see that. Wow, it's about as close to zero as you can get. In fact, let me check the zero on my meter because it drifts a bit. Zero it for super precision. Okay, so we're getting no real. Ooh, it went negative. Actually, that's positive. I've got the meter set so negative is upscale. Let's feed a signal into it. I'll leave the meter disconnected, and we will now connect up here. My signal generator is protected by a capacitor in this box here, just in case you're wondering. Okay, here's something coming out of the speaker. It says to do this with a unmodulated signal, but I've got a modulated signal going into the radio at some frequency around 50. Turn the volume up, make sure the volume's up. Volume's up. RF gain is up. Okay, so I think we should be hearing a tone, 1000 hertz tone. So what we'll do is we'll raise this. And I'm going to vary the frequency, and we'll see if we come across it. That thing. Okay, we're going to go up another step here. And okay, so we're not doing so well. No, let's watch the meter. Maybe this produces no sound. Can't imagine that. Let's put this on positive. We can go upscale for now anyway. Okay, vary the frequency here. I don't see anything happening on the meter. Well, either something's wrong, or something's wrong, or something else is wrong. One of those three possibilities here. I check the meter to make sure I've got it connected correctly by feeding into it a test voltage and making sure the meter operated the way I expected it to. So I don't think I've got the meter connected wrong. The meter itself. Connected to the wrong place in the circuit? I just highly doubt it with the amount of effort I put into verifying that. Still not enough signal being fed into the radio. Oh, it said it should pull out tube 3 to avoid interference, but I'm not sure we're suffering interference here. Let's pull out tube 3 and we can see what happens. Let me vary this again here. No, there's just nothing happening at all. So what do you do when this doesn't work? Go drink coffee for a while, that's one thing. Jack it up to an even higher signal level. Now it doesn't give any hint on the signal level that you need to supply to the radio. Let me check the calibration on this guy here. Oh, it's way low. It's way low. Let's go down. It's way off. Okay. Hear anything? How did this get to 128? It says 128 now. 128 instead of 50. How did that happen? Turning this up. So I was on this frequency probably the whole time. and my frequency counter couldn't see it. It's bottoming out at 60. You gotta go to 50, man. And your scale says 30 to 90. I've never used it on this scale. Well, it's not gonna go down there. Oh, there's another scale. Holy smokes, this goes down to 10 kilocycles. 10 to 30. Okay, let's give it a try. Wow. 10. I mean, you could hear this. This, well, 10. You could hear that if it's loud enough. It's all over the map here on my meter because it's probably too low an output. It's getting a little more steady. Okay, let me read that right off its own scale here, if I can see it. Oh my gosh, this is not convenient. What is going on? Ten, 15, 20. Yeah, 20. Oh, this only goes up to 30. What am I thinking? Yeah, okay, so maybe I'll everybody get that? 280. How can it be 280? Can't be 280. We got big problems here. We got problems. I'm losing my mind. 30 to 95. Why are you doing that? So that seems right. That seems right. That doesn't seem right. Well, I guess maybe I'm going to have trouble going down to such a low frequency. I can't rely on this guy. He's not getting enough signal to do the job. Giving it more signal now. So I'm directing more signal towards this thing. Hey! Okay, we got there. That took a while. We're full volumes here. Now, what about our meter? Is the meter doing anything interesting? It dipped here when this radio's gone distorted. Almost certainly from overdriving this signal. Isn't the meter supposed to be swinging up and down? It's not going to do much good like this. Out of the pan, into the fire. What to do, what to do. Okay, so we're feeding in a signal that is still high enough to cause distortion in the radio, and it's quite low at this point. This is a low setting. Radio's operating with 111 volts. That's plenty. Right. I really need this to work. The meter here. Something's wrong with the radio. That could always possible. There's something wrong with the radio, and I'm encountering it, and that's why this test won't work. That's not very likely, though. That's very unlikely. Wrong test point. As much as I like to think I was super careful, I'm looking right at it. I can see the terminal from the. You can't. You're still looking over there. Look over here. So I'm considering whether this is in the right spot. So here it goes to a terminal. This is terminal. What number is it? Well, I'm gonna, this is a long process here. I'm not sure I want to drag you all through it, verifying this. There's really no doubt I've got this right. So I never pulled out that tube. I should pull out the tube. It was V3. I identified it and I pointed to it so I would remember. And it's yeah. I can't just pull the tube out here again. I'm going to have to re-identify it. Okay, I'm going to stop the video. We'll get that done. Okay, I've remembered which tube it is. I'm going to pull it out with the radio operating. You can see my arm going in. Tube has come out. The tube is a 6C4 oscillator tube. And that should be C3. Somewhere I don't know. I'm not going to check it. I'm sure that's correct. Made no difference in the sound in the radio as far as I can tell. Where are we at now? So what are we actually discovering? Let's see what we can discover at this point. So this is supposed to be a 50 kilohertz signal. Well, I would say it's pretty clear that something's happening right here. 53. The instructions were to not use it, to use a unmodulated signal. Well, how would that make any beneficial difference here? You wouldn't hear it coming out of the speaker. Hey, wait a minute. That tone we're hearing, yeah, that tone's not coming from here. There's no tone. This is not modulated anymore. Oh. So what's happening to me in here now? That's a high, you can hear that high-pitched tone. If I move my head just the right way, the sound disappears completely. Well, there's interference waves happening in my shop here. So that when I went, oh, it was because the sound had disappeared from the radio, just because of the angle of my head. That's about all my head is good for. But well, so I pulled the tube out to get rid of interference. Now we're become aware of an interfering tone. What do we tune this? So we're hearing an audio tone. The audio tone varies when I vary this frequency. It goes all the way down to nothingness. Then we get that. Then it comes back up. So to me, that's a heterodyne between two frequencies, one fixed in place and one I'm moving. As I move the moving one closer to the one that's fixed in place, the tone goes down. Because the heterodyne combination results in a lower and lower frequency until you get to 0. At that point, this thing is apparently right on top of the tuning of the IF 53 kilohertz, it looks like. And it sort of takes over, swamps the whole thing. But then as I move it out, begin to hear the tone redevelop, the heterodyne tone, as if you're leaving another frequency behind. And there's an oscillation there at 50 kilohertz. Really? I don't know. I'm trying to come up with some thoughtful way of explaining all these things. So as for the tuning does seem to be off, even though the test tones and that they're not very inviting. Really, it keeps telling me something's going wrong. This meter is not responding the way I expect it to. So I've almost got a short down here. Ooh, that was close. I almost got these two clip leads to join there. I don't think that would be a good idea. Well, I'm going to leave it here. I have to go do other things. We'll start here tomorrow and try to sort out the test here. Have I made a mistake? Did I misread the book? Or is there something wrong with this radio? And for instance, the oscillation we're hearing that's causing the heterodyne shouldn't be there. I don't know. Okay, that's for tomorrow. I'm heading outside now. I continue working on my retaining wall, which I am reconstructing in my driveway in the sunshine. Thanks a lot for watching. This is going to be a tough slug. I don't doubt it. I'm going to be very careful as I do this. I want to get this radio working at 100% if I can do it, because I think it has great potential. Thanks a lot for watching so far, and you enjoy your day. I'm off to work. See ya.